There's another kind of variation that goes along with direct variation. Let's call it inverse variation. Now, as we just saw with direct variation, as one quantity increases, so does another one. Inverse variation is going to do the opposite. And you see phrases like this, that y varies inversely as x, or you see that y is inversely proportional. Y is inversely proportional to x. Okay, those are the key phrases that we're going to see. And if we see this, it would be translated like this. Y is equal to k divided by x. K divided by x. Okay. What did direct variation look like? It was k times x. Inverse variation is k divided by x. Okay? And what this guy says to us, as x increases, what is y going to do?
Decrease.
Y is going to decrease. Or, if x were to decrease, that means that y is going to do what? Y is going to increase. Okay? Now, it may be tough to think of examples like this with inverse variation. But let's think about it this way. You know, you guys like to throw parties. You like to have a really nice spread, maybe with a bunch of chicken nuggets, right? And
Some hot wings.
hot wings, chicken nuggets, it's all the same. Okay. Here's the thing. As the number of people increases, then the number of nuggets per person does what?
Decreases.
It's going to decrease, right? See, I always think about this when I'm eating at my in-laws' house, and if my mother-in-law makes a cheesecake, the more people that are there, what? The less cheesecake per person, right?
Yes.
And I start to get a little bit miffed about that. So I'm like, can I just have my own cheesecake? Because see, if it's just me, how much of the cheesecake do I get?
The whole
The whole thing. If there's 2 people, how much do I get? Half. If there's 4 people, a quarter. Wait a minute, I don't like this. More people does not mean more cheesecake. It means more that I have to share. And as we've already established, I'm selfish. You guys laugh like you don't believe me.
Thanks for sharing.
Now, we just did an example of direct variation based on working. The more you work, the more you get paid, right? However, there is a situation that deals with inverse variation, and that's salary.
Oh, no. We don't like that.
You don't believe me?
So we don't like that.
Because think about this. If you take your hours and you increase them, does that increase your pay?
No.
No, it decreases the amount of money you make per hour. That's going to go down, right?
Oh, yes.
Because if you get salary, it doesn't matter how long you work, how much you work, you just get paid the same amount, right?
Correct.
Now, it could be something like this. That your hourly rate, we'll just call that R, is going to be your salary, whatever that is. Let's say your salary is $80,000. Divided by, let's say, the total number of hours that you work. Okay, this would have to be for like a whole year, right? So as I increase the number of hours, then my rate of earnings per hour is going to go down, right? So if I were to stay up here 6 hours extra every day doing stuff, I'm not getting paid for it. I might feel better about what I'm doing here. Okay, I'm also going to get worn out, but that means that the amount of money that I'm getting paid is going to get less and less and less as I go on there, right? As opposed to if you're working an hourly job, the more hours you work, the more you get paid, and then it even goes back to that piecewise defined function that we talked about with overtime, right?
Yes.
Okay. Well, just to let you know, my pay is very difficult to come up with. Part of my pay is salary. Not that. Okay. And the other part is, it's kind of hourly when I talk about overloads. You have salary plus additional assignments, and those are calculated differently. It's crazy. I rarely have I do not go through the whole year with the same paycheck.
Oh, my God.
It's a roller coaster.
That's not good.
Did they pay teachers during the summer? They're not